This Artificial Intelligence and Equality podcast is hosted by Carnegie Council Senior Fellow Anja Kaspersen. Together with Wendell Wallach and an international advisory board, they direct the Carnegie Artificial Intelligence and Equality Initiative, AIEI, which seeks to understand the innumerable ways in which AI impacts equality and international affairs. This episode features Francesca Rossi. It was recorded on February 11th, 2022.
I am thrilled to today be joined by Francesca Rossi, who is a dear friend and someone who really inspired and been driving efforts towards ethics in the field of AI research. For those of our listeners who are not familiar with who you are, Francesca, allow me a quick introduction. Francesca is a former professor of computer science at the University of Padova in Italy, and is currently a fellow and AI ethics global leader for the International Business Machines Corporation, better known as IBM. I'm really excited to do this deep dive with you, Francesca, on the current state of AI research. But before we get started on your research interests, I would like to ask you what sparked your interest as a young girl growing up in Italy to pursue this, what has essentially become a lifetime adventure in computer science and more recently, artificial intelligence.
Thanks, Anja. Thanks for the invitation, for the opportunity. So what convinced me to get this journey? But at that time, it was not really thinking about AI, but thinking about computer science in general. No? So I decided to study computer science, which at that time was a very new kind of study. I'm not sure what really convinced me, but I was always attracted even during my high school, to technical studies more than the humanities or the other sciences. So I guess I was attracted to some study in that space. And also I was intrigued by the fact that this was a very new curriculum. And then I continued and I decided to stay in academia, even after my studies and my PhD. So I stayed for 25 years in academia. And then I more and more I developed, the focus on AI rather than, in general computer science. And then in 2015, I went on sabbatical to Harvard at the Radcliffe's Institute, where every year there are 50 fellows from all over the world that cover all the disciplines. So I was the only computer scientist, and then there were people covering all the other sciences, all the humanities, all the arts. And then what they do in that year that you are there, they force these fellows to work together, which is something that was not something that I was used to do, because usually I was talking to my peer computer scientists and not to these other people. And these other people, when I work with them, I spend time with them, they were asking me questions that were very different from the usual one that I was used to consider. So they did not care about my latest theorem or experiment or result in my research, but they cared about the big picture, about the impact of this technology, about what I was doing and in general of AI. So that's where I started thinking about these more societal, considerations about pervasive use of AI in society and the impact on people, on the way we live, the way we work, and so on. And that year was very, really important because, again, I started thinking about these issues. It was also the year that many other people started thinking about these issues, and the AI ethics really took a big jump forward around 2015, I think. I joined the Future of Life Institute and all the other initiatives that started. Now the space is very crowded with initiative, but at that time, which is not many years ago, it was not. And then when I joined IBM, I decided to move from academia to a company with a significant research environment, because I thought that I could really have an impact in research like I always had, even being at the university, but also an impact on really the responsible use of this technology in practice. And this is something that academia does not give you this possibility of being impactful in that way, while being in a company, it allowed me to have that kind of an impact. So now I spend my time, yes, some of the time doing research, publishing at conferences and so on, but also doing internal policies, governance, and also working with external communities, policymakers, and so on. So that kind of impact was provided to me as an option by this corporate environment where research and business go together.
I find this very interesting, Francesca. So if I hear you correctly, the transdisciplinarity that this course offered really was one of the driving forces of sparking your interest in the broader field of ethics in computer science.
Yeah, so that until then, I was mostly advancing AI capabilities, but I was not really asking myself many society-related questions about this technology. While in that year, really, I changed because these people, again, they were asking me questions. They were not about technical issues, but they were about social technical issues. So that's where I started. And it was a coincidence that it was also the year, I think, that many other people started to think about these issues. And these various initiatives started to being put together. So it was very instrumental for me because AI ethics is about multidisciplinarity. You cannot talk or discuss about AI ethics if you just discuss among technologists or among only philosophers or among only sociologists. You need to have a multidisciplinary environment. So for me, it was very, very important that year spent with people that were not my peers, were very different from me.
Based on what you share with us already, do you find that in the corporate environment, there are more of these lateral expertises that questions the societal impact more so than in the academic environment?
I think that now in academia also, computer scientists and AI researchers in academia also ask themselves these social technical questions. Like, for example, even all the major AI conferences, when you submit a paper, they ask you to write something to discuss the societal impact and possible negative impact of the work that you're doing. So while when I was in academia, it was not like that. Computer scientists were thinking about computer science and sociologists were thinking about sociology and so on. So things have changed, I think, also in academia, but definitely in a company producing AI and delivering AI to other companies. In the case of IBM, we deliver AI to other companies for their operations or their services. Then you cannot just be internally looking. You have to listen at what clients need, but also what all the other stakeholders are thinking. It has to listen at what society, clients, consumer rights advocates, policymakers are doing in order to fit well, and to bring the vision of the company into an environment which is made by external actors. So definitely in a company, I find myself discussing much more about all these other stakeholders and with these other stakeholders than when I was in academia.
And Francesca, you are now the global AI ethics leader for IBM. What does this role entail and what does your workday look like?
Well, first of all, I co-chair the internal IBM AI Ethics Board. This is the centralized governance within the company that makes all the decisions about AI ethics. So I am one of the chairs. The other one is the Chief Privacy Officer of IBM. Okay, so privacy and ethics together. And the members of this board are representing all the business divisions, from research to marketing, to products, to AI solutions, to legal, to everything else, okay? All the business divisions. And not just representing, but the people are the top people of these divisions. So the people that once the board makes a decision, then they go back home and they can implement that decision. So it's not just one generic person in that business unit. And what the board decides is internal policies and processes. For example, building a methodology so that all our developers team can understand how detect and mitigate bias in the AI models that they build. You know, how do you build this methodology? Which tools do you need to provide them? How do you make this methodology as easy as possible to be adopted, as integrated as possible with the other processes that they are already, you know, following? So that's something, one of the work streams that was put together by the AI ethics board. Another thing is educate all the IBMers around AI ethics and the various issues. What is AI ethics? How does it relate to my role in the company? So we have specific, very deep educational modules for the developers, but then we have also generic modules for everybody else, like in our yearly, you know, course that we have to take, the business conduct guidelines. There is a part on AI ethics also that everybody has to take. Another thing that the board does is to examine all the offerings that the company has towards any client in any part of the world that may raise some issue, may have some risk related to AI ethics. So there is a whole process in place that allows, you know, from the team that wants to deliver something to a client, the team has to talk to a focal point, that's a person representing the board in every business unit. And then this focal point can be the first filter. And then if he thinks that there is enough risk, then the whole board discusses this offering. And sometimes, you know, and the result of this discussion of the offering can be, yes, it's fine the way it is, we like it, you can go on, or no, we don't like it, but there may be some way to add contractual constraints on the contractual agreement, so that, for example, usage restrictions, that if you add this user restriction, then we are fine with providing this to our clients. Or in some cases, we even say, no, I'm sorry, we don't like it. We don't like it because the technology is not good, or because the use is not good, or because the client is not aligned to our values. And so in some cases, we even say we don't see any way to make this align to our values, and so we don't deliver it. So that's another big work stream of the AI ethics board. And then we even do things, sometime at the beginning, we even did things like defining, putting together a glossary of terms around AI ethics, because IBM is such a big company and distributed, you know, all over the world. So we realized very soon that many people were using the same term with different meanings, or different terms with the same meaning. So there was a lot of confusion. We couldn't really talk to each other and understand well. So we said, okay, let's write down a glossary. What do we mean by AI ethics? What do we mean by AI fairness, AI explainability, this and that, you know? So, and so that everybody has some place to say, okay, when we talk about that, we mean that. So again, all these initiatives are because we started with very high level principles that, as you may remember, everybody was having principles a few years ago. No, we started with these principles. AI must augment human intelligence. Data belongs to whoever provides the data, and it has to be explainable and fair. And then we said, okay, but our developers cannot use these principles to understand what to do in their everyday job. So we really needed this governance and all these work streams of the board to really operationalize these principles. Say, okay, these are the principles, but now we need to go much deeper into concrete actions that are aligned to those principles. Otherwise, we're not going to change our operations if we just tell people our principles. So that's what you know, the board is about. You know, the way to operationalize the principles, in a coherent way in such a big company. That's not easy. And also in a way that is integrated, with what the various people in the company are already doing. And another activities also supervised by the board are all our partnerships with external multi-stakeholder organizations or policymakers, the UN, the World Economic Forum, the European Commission, and this is important really also with what you said earlier, now to listen to what everybody is saying and doing, learning from listening, but also bringing our own experience into these places, our own lessons learned, and working together. So for example, IBM does not have an external advisory board on AI ethics. We decided consciously that the best way to engage with everybody else is not really to have a fixed set of few people that advise us from externally. So that to us, it's a much better way to really work together with everybody else. So in the recent years, really, I would say that the focus was really in operationalizing the principles, making them concrete, transform them into policies and processes in a coherent way and within the company. So that's the role as AI ethics leader. Of course, I'm not doing everything by myself, and there are so many people, but, and actually what we learned doing this is that in any company, it doesn't make sense to appoint somebody as the, I don't know, AI ethics global leader or chief AI ethics officer, whatever you want to call it. It doesn't make sense to say, oh, I appointed that person and now I'm done. That person will take care of everything. It has to be really a company-wide approach in order to operationalize this. Everybody has to be involved. Everybody has to be aware of what is done by the board, all the initiatives and so on. So it's really, it's not just one person or a team that can address these AI ethics issues. Sometimes there are media, journalists that ask, so tell me, what is your AI ethics team? And we say, well, we don't have an AI ethics team. We have the board, the focal points, the advocacy network, the this and that, and it's a company-wide approach. So that's very important lesson. The other important lesson was that at the beginning, the board was less able to really make decisions, was more like a way to discuss and be aware of what each other was doing. And it was reasonable because at the beginning, people just needed to understand what is this AI ethics, how is it relevant to my operations and so on. So, but then after a while, we really understood that we needed to have a much more powerful board in terms of making decisions and then decisions being, adopted. And so we restructured the board for achieving that.
So Francesca, allow me just to follow up on the point you made on explainability, which is obviously a big one when talking about oversight and governance of AI, and is key to any discussion on ethics. Do you think that we are in a satisfactory place with regards to explainability? And for our listeners that may not fully grasp the issues that exist around explainability, what are the big hurdles? And are we making any headway in addressing them?
So explainability is still ongoing work. Also fairness and others, but explainability especially because it's a technical issue, because explainability means that the AI system itself, not the human being, but the AI system itself needs to be able to explain to a human being why is making that recommendation. Okay, it tells you, oh, I think you should choose that thing and not the other one. But the AI system itself should be able to explain why. So that means that the AI system must have some notion of causality, it says, okay, you have to do this because there is this other thing that caused me to say that you should do that. So, and that's not that easy, especially when you are using some of the most successful approaches, which are based on data and machine learning and deep learning. You may have different kinds of data. You may have a system that is based on images in input, or text, or structured data. So, and each one of them needs a different technical solution to allow this system to provide explanation. So there are some partial solutions, like explanations based on correlations with other input data similar to the one that was just received, and so on. So there are some partial solutions, but another challenge is that you may have to provide different explanations for different users. So, like, for example, in the healthcare domain, you may want to provide an explanation to a doctor, or to a nurse, or to the patient, or to somebody else, or to the auditor, or to wherever. So for each one of these recipients of the explanation, you have to put in place a different explanation, not contradicting the other ones, of course, but with different terminology, different level of detail. So it's not just one explanation and it's fine with all the possible people that are going to use that explanation.
Because I think that's a concern that many of us have, is that we increasingly and often mistakenly treat the systems as providing, as you said, causation and consequence, but very few of the systems is actually set up and programmed to do so. Right. They provide correlation, and then you need that human component to really be on top of it to provide a wider context.
And in fact, one other challenge, I would say, of explainability is that whatever you put in place and you provide as an explanation, the user of that AI system, or whoever, it needs to be trained, needs to be able to interpret what the system is telling this person, because it cannot mistake, as you say, correlation for causation. It should be able to understand what that means, and not make inferences that maybe are not appropriate. So it should be able to understand the capability of the AI system and the framework of that explanation that is receiving. So the training of the operators, of the human being receiving the explanation and using this AI system, is very important.
So essentially making sure that there is optimal maturity in the system before it gets embedded, so that we avoid a situation where we display an overconfidence in the system and underinvesting in the people that is actually becoming instrumental to operating the systems in a safe manner.
Yeah, definitely. Now we just talk about the people using an AI system, but of course there are also the people building the AI system that need to be aware of the possible, for example, bias, that unconscious bias that they put in whatever they do in their everyday job. So they need to be able to work in a possibly diverse environment. They need to be able to talk and to understand each other with people that are not technical. To consult with them. So there are all these actors around an AI life cycle that need to be trained and educated and enter into this frame of mind of dealing not with the technology, but with the socio-technical environment. So it's important that all these actors don't think that everything can be solved by a completely technical only solution. Not probably the service that you're putting in place. It cannot be probably, especially the high stake, when there is a high stake decision, it cannot probably be completely automated. It needs to be an interaction. And also, even the things that you do while you're building a solution, even the bias testing, it cannot be just completely automated. It has to be something that the human being thinks about it. Okay, so what could be here the impact on some protected variables? Do I see them in my model? Race, gender, age. Or if I don't see them in my model, maybe there are other variables that are proxies for those. So how do I understand, whether really there is risk or not? So, and in this, there is no technical tool that can automate that. So the role of the technical tools and the AI-based tools is very important, but it should be understood that they are not the complete solution. So what I'm doing right now is, the biggest project that I have at IBM, but also in collaboration with many external academics, is about trying to leverage cognitive theories of how humans make decisions, and in particular, Kahneman theory of thinking fast and slow, to be inspired by that theory in trying to advance AI capabilities, given the observation that there are many things that humans know how to do, and machines still don't do. So, for example, recently we put together an architecture, and we inspired by this thinking fast and slow, where there is a machine that has some fast solvers defined in some way, some which are similar to the features of our thinking fast, meaning, our intuitive way of making decisions without thinking too much, without reasoning, just based on past experience, and then replicating what we know how to do well. Thinking fast is what we call system 1, okay, which is our intuitive, very fast thinking, almost unconscious thinking, not even aware. We make decisions 95% of the time. We make decisions that way, and then instead the thinking slow is when we really decide that we need to put a lot of attention in whatever we need to decide on. And so with all our attention, we're very careful, we follow a procedure, and we reason about the problem, and we get to a solution. And usually we do that when we're not familiar with the problem enough to be able to use our intuition. And that's thinking slow is also called the system 2. So in this machine that we put together, we have some processes that are similar to our thinking fast. So wherever a problem comes in, they always activate, and they just come up with a solution, which sometimes is a bit, not really well thought. And then it has also some processes that are similar to our thinking slow processes, or system 2. So they're very careful, and they take more time, but they usually get a better solution. And then we saw that in this machine, by putting together these solvers, the thinking fast, thinking slow, and a metacognitive part that decides which one is best to use in every scenario, we saw that we achieve a behavior similar to what we see in human beings. So the behavior, so-called skill learning behavior, where when we are not familiar with the problem, we initially tackle it with our system 2, so thinking slow. But then after a while that we use this thinking slow many times, we can actually pass to the system 1, to the thinking fast, because we have accumulated enough experience that we can, that at that point, system 1, or thinking fast, can take over, and so producing a high quality decisions, just like using system 2, but in much less time, in almost instantly. And we saw that behavior also in this machine, where, over time, in a simplified decision environment, over time, the machine goes to using mostly system 2, and then later on it uses mostly system 1. So we saw a similar skill learning mechanism than in human beings. So that's one example, of what this project wants to do. The project overall goal is to build machines that can, inspired by these theories, cognitive theories of how humans make decisions, they can really exhibit some human behavior by the machine. But also there is another important goal, which is to build machines that know how human beings would make that decision. And because of that, they can help human beings avoid our pitfalls, our fallacies in making decisions. They can alert, they can nudge, they can tell us, look, I think you are going to use system 1 here, but I think you should not do that. You should use system 2, and I can help you in doing that. Because sometimes we don't use the right modality and we can make mistakes. We have bias, as Cunningham said in his book, we have noise, we have many other fallacies in our making inferences and making decisions. So the ultimate goal is to build machines that can actually help us recognize our possible fallacies, especially when we have to make decisions that can have a significant impact on our life or other people's life or society in general.
That I find is fascinating. We're essentially trying to code a machine to have a gut feeling, and then to overcome that gut feeling or to back it up with some rational thinking. And it's interesting that in neuroscience more recently, there's an increasing acceptance that in the end of the day, humans make decisions based on our gut feeling. And then we use our brains, so the slow thinking, as ways of rationalizing the decision we already made with our, we already made with our gut. So is that what you're saying? You're trying to test if the machine can have a gut feeling and then back it up with post-rationalizing its thoughts, or it will help us to distinguish between our gut and our more cerebral processes?
Well, okay, the idea is to investigate this space, you know. So, but again, the one of the long-term goals is to really help humans recognize when they probably should not use their gut feeling, but they should use something else, more careful analysis of the situation in order to make a better decision. So usually we use system 1 when we feel that the problem is cognitively easy, very familiar, easy, let's just, not think about it, just make a decision. When we feel that the problem goes beyond a threshold of cognitive easiness, we say, oh, okay, but better be careful here, I'm going to use system 2. But when the problem becomes overwhelmingly difficult for us, in some sense, we go back to system 1, because even our system 2, oh my God, there's too much data, too much criterion. And so we just simplify the problem so that it can be handled even with the gut feeling sometimes. So that is one of the typical scenarios where, especially again, if the decision is a high-stake decision, where machines could help us, because they say, okay, I understand that here is too overwhelming for you, but let me help you with that handling of these amounts of data and so on, so that we can still use a system 2-like, solution or process, even if by yourself you would not be able to do it, and that can achieve a better solution. So that's the idea, is to really have a machine that can help human beings interact with them by knowing how humans would behave, in various scenarios. But also, as I said, in these first experiments that we did, also to have machines that exhibit a behavior similar, like the skill learning, similar to human beings, and what that means in a machine. Because of course, we had to make design decisions that are for machines. I mean, not necessarily we are replicating what happens, first of all, because we don't even know completely what happens in our mind, in our brain, but also because what is a good design choice for a human being not necessarily is for a machine. A machine has different capabilities, different properties. So it's a completely different platform to build something, so that was a very interesting, is still a very interesting project. But the first part of the project, where we really were just brainstorming about this relationship between cognitive theories and AI, was, very, very interesting. And now it's even more interesting to see the first experiments and what they show and so on. And it's very nice that even in a corporate environment, there is some space for very long-term research projects, because this project is not going to bring this year, anything, or even next year, anything to a product or to a solution or to an offering that is useful for IBM with our clients, So it's a long-term a long-term project that while doing the project, you may have like some spin-off that can generate maybe more concrete and short-term things, but it's nice that there is a space also for this long-term thinking. And so it's very nice also to work in a very multidisciplinary research environment.
Building on that, Francesca, could you elaborate for our listeners the difference between machine learning and the broader field of symbolic reasoning, which you have alluded to, which has often been described as more traditional AI?
Yeah, so now I work in both areas, and this project is actually can be seen as a way to combine both areas, because in some sense, in a very imprecise way, one could say that system one could be implemented like by using data-driven and machine learning approaches, and system two more by symbolic AI. So machine learning just means, in the case of supervised machine learning, it just means that the machine learns how to solve a problem by looking at examples of solutions. So, for example, if you want to build a machine that can decide whether to accept or reject a loan application, okay? So you give the machine a lot of examples of loan applications, and for each loan application, you tell the machine whether it should be accepted or rejected. Okay, so you give the solution for those loan applications. And then the machine takes these examples as training data, and it adjusts its parameters in a way that hopefully it behaves well, correctly, also for a loan application that has never seen before, not part of those examples. So it tries to learn from these examples to provide the correct solution also for other input data. So in some sense, machine learning, supervised machine learning, means that we human beings are not telling the machine exactly all the steps, step 1, step 2, step 3, to solve a problem. But we tell the machine, these are the examples of problem and their solution, and learn from that. So instead, in symbolic AI, we tell the machine how to solve a problem by communicating the steps to do in order to solve that problem. So you say, okay, like you would do like in a recipe, no? A recipe, okay, you want to bake a cake. So these are the input that you need to have, the ingredients. And then step 1, you need to mix this and that. Step 2, you need to do that. Step 3, you need to boil that, and so on, until you get the output. So that is a sample of symbolic and logic-based AI. And instead, for some problems, unfortunately, we don't have a way to tell the machine the recipe, the exact steps on how to solve a problem, because the problem is too vague and too the input can be so diverse that it's not possible for us to tell the exact set of steps. So, for example, if, again, in the same example, if you want to tell, okay, given this loan application, I tell you, if you see this, that, if you say that. So if you want to know exactly the steps, it's not easy, and they will not, whatever you write down, how careful you are, you will not have the same correctness rate, the same accuracy as something that can learn from the data. Another typical problem, even more typical of this need for data-driven approach, is when you build a machine to interpret what is in an image. So, or to, so in that case, it's too complex to tell the machine exactly, if you see this in this pixel, then you need to do that, etc. So you cannot do that with the symbolic approach. But you can, and with high accuracy, you can do that with the machine learning approach. Many typical AI applications, for many years, researchers have tried to use symbolic AI to tackle them, like, for example, language translation from one language to another one. But then machine learning showed that with the data-driven approach, we could achieve a much better accuracy on that task. Now, that doesn't mean that symbolic approaches are not useful anymore, and you can do everything with machine learning, because if you learn how to solve a problem from data, then in some sense, for example, you lose explainability and traceability, because if you don't see the steps that were done, then you say, oh, okay, the system tells me that this loan application is rejected. Why? Why is it rejected? I don't know. There are a million parameters in the neural net. Who knows? No, I need to really to build additional technology in order to do that. While if you have a sequence of steps, you see very clearly what generated the rejection down here as the output. No? So you lose something. And also, there are some situations in which you don't have a huge amounts of data that are needed to have a good accuracy with machine learning. So there are some situations where you have a lot of domain knowledge, but not a lot of raw data. So in those situations, it is not really easy to find enough data to have machine learning work well. Also, we would like machines to learn general concepts and possibly to reuse what they've learned from one problem to use it in another problem, so that in the other problem, they don't need to start learning from scratch. And like we do, human beings. So once we learn about horses, that's a typical example. You learn what's a horse, then to learn about a zebra, they just tell you that zebra is like a horse with stripes. That's it. You don't need another huge amount of data with images of zebras and so on. You just need one piece of information. But this piece of information is expressed in an explicit way, in a symbolic way. So that's why we would like machine learning also to learn symbols and not just to learn how to give a correct answer based on raw data. But there are many, there are a lot of people working in machine learning approaches, but trying, it's obvious to many now that, the trend is to try to embed symbols and symbol learning, concept learning also in machine learning approaches. So it's obvious that you need to be able to leverage the data, because if the data is there, you need to be able to leverage it, especially for some problem, but you also need to be able to work with symbols, especially if you want machines to interact with human beings. We talk in symbols. We don't talk in terms of raw data or parameters of a neural net. So the two things, I think it's more and more clear that the two approaches to AI, symbolic and data-driven, need to be combined in some way. Now, how to combine it? It could be, like the approach that we are taking. It could be other ones, but it's clear that there are good and bad things in both approaches. And if you really want AI to significantly advance its capability, we need to get, the good parts of both approaches.
And how do you view efforts to embed more symbolic reasoning as a means to respond to current toxic language models that are clearly not working at purpose, and also demonstrating our over-reliance on data-driven models, sometimes providing for less than optimal and inaccurate outputs?
Yeah, well, I mean, when you only rely on data, it's not easy to bound, the behavior of this system with some explicit boundaries. Like there are some things that you should, there are some decisions that you may not want to take. There are some values that you don't want to violate. There are some constraints that you don't want to violate, and so on. So it's difficult to say these things and to embed them into a machine if you just rely on data, even though there is a huge amount of data. And it's also difficult to be robust, no? When you just rely on data, and to be smooth, meaning that a small change in the input, smooth means it should not generate like a big change in the output. So that's smoothness or related to the notion of robustness, no? And so when you change the input a little bit, you may see a small degradation maybe, but not a big change. So if you want machines that you can trust, and use and trust about, following what they tell you, what they suggest you to do, and so on. Robustness, for example, is an important feature. Explainability is an important feature. So if you just rely on data, yes, you may have like large language models that are amazingly good in generating English valid, they write much better than me, in English, but sometimes they just go all the way in a completely different direction than what you were expecting. So they say things that are not relevant from what you asked. They may say things that are even ethically unacceptable. So how do you bound this behavior? It's not easy to understand how to do that if you just rely on learning from data, say. But again, there are so many approaches, and it's amazing. I mean, the amount of researchers, AI researchers from all over the world grows every minute, and there are so many every year at the conferences. I'm looking at Triple AI that I know more familiar, but new RIPS and other conferences on machine learning at each CHI and so on. So there are so many, and they're growing very, very rapidly with all sorts of techniques. What is a bit worrisome is that, but I don't think that now is the case anymore, that at some point these machine learning approaches were so considered the solution to everything that even the new generation, the PhD students, were not even taking courses on AI, but just on machine learning, not on other techniques in AI, because they thought that, but now I don't think that's the case, because I really think that everybody understands that you need to have in your hands all the techniques and the good things of the various techniques in AI, and definitely machine learning is one of them, in order to significantly advance AI. Otherwise, you just, you get one more example, one more benchmark, one more application of another fine-tuned machine learning technique, but you're not really advancing AI capabilities. So I think that people understand that you need also these other symbolic techniques to be combined in some way.
This is a very nice segue, Francesca, to the broader issue of ethics and AI, which is a vast field, as you have alluded to, and also a increasingly crowded field. You mentioned, when we both started working on this now 7-8 years ago, it was hardly anyone who was discussing this issue related to AI. Are you concerned about the sort of the risk of ethics washing? I still think there's a lot of merit in ethics because it allows us to look at options chosen, but also the options and roads not taken, and to deal with some of the tensions that will come out of some of these trade-offs that you were alluding to in your own research and in the work of your company and other companies. There will be constant trade-offs that we have to grapple with, we must grapple with. And ethics is the tool that allows us to really explore, investigate. Where do you see the ethics space and where do you see it moving forward?
So at the beginning, it was an awareness period. And then after that, there were the principles period. There were more than 100 sets of principles from all over the place, from companies, from governments, from multi-stakeholder organizations, from academia. So principles all over. You may remember that Harvard had a project called the Principles AI project, with even a visual, a round visual about all the sets of principles that had been published, and there were more than 100 already in 2018. So awareness, then principles, then policies. Say, okay, how do we start operationalizing these principles? Let's define some policies. Then from policies to actual processes, that concrete processes that people use to to be aligned with those principles and implement the policies. And this, we are now really in this era of AI ethics, doing practical things. You know, you can see standards being finalized. You can see internal processes for corporations that are being used. You can see regulations that are being proposed, like the European AI Act, or even adopted, like in New York, in New York State, or in other states in the United States. So, I mean, it's a really complex and path that AI ethics went through in, I would say, few years, because as you say, 2015, there was nothing of this, just some initial discussion. So going from awareness to principles, to to practice and policies, and then the practice, I think we did a lot of work. I mean, and that it has a concrete impact on the AI that is being used all over the place.
You mentioned the efforts of European Union earlier, Francesca, and you served as a member of the European Commission High-Level Expert Group on Artificial Intelligence. Can you speak a bit more about that process and your key takeaways?
So that European Commission High-Level Expert Group on AI, it's a group that was nominated by the European Commission, but was worked for 2 years, completely independent of the European Commission. What we published, what we wrote, was not guided by the European Commission. And these 52 people were very diverse, you know, some were from academia, some were from corporate environments. There were AI experts, but in 52 people, I think there were less than 10 AI experts, I would say. And then there were philosophers, psychologists, sociologists, consumer rights advocates. So very, very diverse group. And at the end, we published several things, but I think the most impactful one was a document about the ethics guidelines for trustworthy AI in Europe. So we called trustworthy AI the kind of AI that had to have 7 requirements, I think, which were related to fairness, explainability, robustness, and so on, all the other things. So based on that document, then the European Commission put together this proposal for regulation of AI in Europe, where the notion of trustworthy AI that was in that was developed by that group is included as the kind of AI that needs to be delivered in Europe. On top of that, then the European Commission in the regulation proposal also put these levels of risks that we did not produce as a group. So the 4 level of risk, you know, the unacceptable risk, the low risk, and then the big one, which is the high risk applications, which require a lot of obligations for the provider, for the user, but also making sure that the AI that is delivered in those high risk applications is trustworthy. So it's fair, it's explainable, this and that, and so on. So, and it has human oversight. So that's the combination that I see. So we started with ethics guidelines. We gave this idea of trustworthy AI 7 requirements, and then the European Commission added these levels of, and the obligations and the levels of risk. So that's that's a way that the European continent, the European Union, is a more homogeneous way to deal with the regulating a technology, like what was done with GDPR for data privacy issues, and now with the AI. In the US is a bit different because there are not many federal laws about AI, but mostly state level laws. So it's a bit more, it can be a bit scattered here and there. So there are some states that already have published laws on related to AI, like related to bias in AI and so on. But there are some other states that did not. So it's a different approach, with more statewide rather than at the level of the whole region.
So recently, Francesca, Margrethe Vestager, the European Commission's digital chief, in a statement said, on artificial intelligence, a trust is a must, not a nice to have. Do you agree with her?
I agree. In fact, that's why at in the European Commission high-level expert group on AI, we use the term trustworthy AI. That's also the term that we use at IBM. Even for a company, there's nothing more important, at least for a company like IBM, there's nothing more important than the trust of the clients, the society, and all the other stakeholders around it. If you lose that trust because you deliver something that then has negative effects, or then it's very difficult to regain it. So the issue of trust is really very important, and is one of the main, I think, I don't see trust as the goal, but I see that as a functional to achieving the goal, which is to have a future where AI is supportive of human values and is improving ourselves, improving the way we work, we live, and so on. But in order to achieve that goal, you need to have this ecosystem of trust around the technology. Of course, it has to be justified trust. So that's why also explainability and transparency are also important, because otherwise you trust, but you need to trust something because there is a reason to trust that entity or that technology and so on.
Evidence-based trust.
Yes.
Thank you for that, Francesca. You've also been elected as the president of Triple AI. Can you tell us what it is and why it is important?
So Triple AI is the worldwide association. It's called the Association for the Advancement of AI. That's the acronym. And it's a worldwide association whose members are AI researchers from all over the world. So it has many activities, but one of the most visible one is an annual conference that is held every year in North America. And this conference is not just American, but it's worldwide, but the participation, the membership, but the conference is usually always in North America. And this conference has papers that are being submitted, and then large program committee that selects some of them, and the papers that are submitted and presented are representative of all the techniques within AI. So you find papers on machine learning, and actually we find more and more papers on machine learning in percentage compared to previous years, but also papers on other techniques that are more like what we said, symbolic and logic-based AI, as well as combinations of them. There are papers also on applications, so there are, and many aspects, all the aspects of AI. There are a lot of invited talks, there are workshops, tutorials. So the conference is really a way for these researchers, used to be a way for these researchers to get together all in the same room, to be inspired about the future of AI, but also to learn about with the tutorials, which are, people telling about consolidated fields to the new generation usually. So to learn about current and AI capabilities and techniques, and also with the workshops to brainstorm in a more informal way about new ideas and so on. So it's a very, very nice event and very inspirational, not just technical, but also inspirational in my view. Overall, is a way to help the AI research community to evolve in terms of the research, but also evolve in the awareness of the issues around AI. And I think that that's very important. I mean, that's from my point of view, is very important that all the AI researchers are, yes, good in improving AI capabilities, but also use their brilliant minds also to do it in a way that takes into consideration the impact of this technology into our society. Already, whoever wants to submit a paper to AAAI needs to discuss the possible impact of his or her work on possible uses that maybe bring a negative impact. But I think that we can do even more and really help the community to really be more engaged with this discussion about these issues, and also providing solutions. So for now, I'm not the president yet. I will start being my presidency in June of this year.
So Francesca, it is clear that there's a lot happening in the AI research field, and we have many more peaks to climb, to use a mountain metaphor. What is in store for us looking ahead? Are there things that concerns you, things that inspires you? And lastly, in your view, do we have the right type of honest scientific discourse also around the limitations of AI, despite all of its transformative impact, to be able to fully cater to the promise it holds?
You're right that AI already has a lot of successful application and useful, but we're just at the beginning, in my view, and there are many things that that we can envision, but we need AI again to be more trustworthy, we say, more robust, more explainable, because if we cannot achieve that level of these capabilities for AI, then it will be difficult to also achieve those other, envisioned, much more important application, like using AI for global problems like the climate or health or other pandemics or other things. You really need to do a significant step forward. So it's like we are using AI now for few things here and there that are important applications that improve the operations of companies and improve many other things. But again, we can do much more with that. So for example, at IBM, we recently started a new research area called Accelerated Discovery, where we try to understand how AI, with its current and possibly future capabilities, can help human beings to really accelerate the process of discovering new things in science, in health, in many other disciplines. I still think, maybe because I've been working at IBM for a while now and I got into this frame of mind, but I think really that many of the future, let's say, vision that I have is where AI is going to work together with human beings and not just in a completely autonomous mode. So that means that we need to think about that context, and in that context to think about what we need from AI. So if we think that that's the vision that we want to achieve. So there are, again, some things that are needed in that context. For example, we said explainability and so on. Others that are maybe less important in that context. So I still see for the future a place where AI should support human beings in improving their life within our, while being aligned to our values. So that means that this AI ethics, in my view, has also to include, an understanding of how to embed human values into these machines, whatever they're doing. How do you embed human values? Can you learn values just from data? I don't think so. Can you embed values just from rules? I don't think so. So again, it's another place where the two things need to be combined. Because one is too brittle, rules are going to be too brittle and incomplete. Data is going to miss some rule that is obvious but doesn't show up in the data. So, so in my view, how to embed human values into machines and how to make machines really help human beings. Remembering that, again, advancing AI is not just for the sake of advancing AI. Advancing AI is because we think that we want a future where the technological progress is helping us to improve, our life, our planet, our societies. So, so it's not just a value per se to advance a technology like AI, but it's a value embedded in a society in order to advance, that society in a way that is aligned to our value. That's why, for example, there are many AI ethics, frameworks, but I always like the ones that refer to the UN Sustainable Development Goals, because in some sense, that gives you a vision of the future. That's my vision of the future, where all the goals have been achieved, right? So how do I use the technology to get to that vision of the future? So that's, now I have a better framing of what to do with AI, right? Otherwise, if I don't have a vision of the future, then I just, let's improve AI, doing this, doing that. Why? In which direction? Why this direction and not another one? So I think it's important to do this reverse engineering approach where you say, okay, that's where I want to go and I am here. So let's try to get towards that, one of the trajectories towards that vision.
So building on your point, Francesca, on getting the vision right and reverse engineer approaches to get a better sense of where you want to go, but also answer why I'm here. I'd like us to conclude where we started, which is essentially, what would you advise your younger self, reflecting on the experience that you gained to date?
Well, the first advice is to do what you like. Because if you do something that you're not passionate about, since you will have to spend also a reasonable amount of time in whatever you choose to do, then you're not going to do it well. You're not going to be happy. Nobody else is going to be happy, because if you do something without being passionate about, probably you would do it at a medium, with medium quality or something. So do what you're passionate about. It may be working in AI, it may be working in a completely different field, but if you want to really have an impact, a significant impact, you have to be passionate about what you're doing. So don't worry about what you're passionate about is not maybe the most trendy thing, but follow your passion. That's one thing. And second, I would say, do not make decisions because of fear. So just, sometimes use your system one, you're thinking fast, and just jump. And if you feel that's the good thing for you, even if everybody else tells you, but that's not reasonable. I mean, why do you do that? If you feel that's the right thing for you, just do it. Don't say, I'm not making that decision because I have a fear, of something bad happening and so on. So when I moved from academia to IBM, it was a big decision for me. I moved to a completely different working environment, different continent, different, environment also for my life. And I could have said, okay, I know the environment already where I am, I like it. It's academia. I'm very familiar with it. I'm in Italy and so on. But I felt that I had the opportunity to have, a different impact that at that point, I was passionate about. And so after thinking about it, and everybody was against that, I don't think I know anybody in Italy who resigned from being a full professor. But at the end, I said, okay, I will take that decision because I feel that it's right for me. So don't be too afraid of making decisions that seem, of course, you don't have to, to be completely unreasonable, but I think that sometimes you have to really follow what you think is right for you, and don't be too scared about the possible, things that can happen. If you are passionate about something, usually good things will happen. So be okay with the fact that sometimes you have to go out of your comfort zone and be open to be in unfamiliar territories.
And before we conclude, Francesca, there's one more thing I would like our listeners to know about you, and that's your creative output. You're also a painter.
Well, I think that I like the creative process, like going from a white canvas to something that looks like it's alive. And I think in some sense it's similar also to what researchers do. Researchers create the future, something that is not there before their work. And then at the end, when the paper is written, there is something that came alive in a different form, not of a painting, but in some sense it's similar to the research and, endeavor, so to create something. So AI people create the future, and that's the way I think about AI. I thought about AI since the start. So in some sense, yes, I see it as a creative, both things are creative activities.
Amazing. Thank you so much, Francesca, for sharing your time and your immense expertise about AI and AR research with all of us. This has been a riveting conversation, which I hope those listening have enjoyed as much as I have. Thank you to all of you for tuning in, and a special thanks to the team at the Carnegie Council for hosting and producing this podcast. For the latest content on ethics and international affairs, be sure to follow us on social media at Carnegie Council. My name is Anja Kaspersen, and I hope we earned the privilege of your time. Thank you.